So what is a string? A string is a series of characters between quotes. I'm going to crank up idle, or anaconda in your case. That really looks interesting. I need to try that. So we're on lecture E as far as I recall.
Yes, sir.
And we're just going to play with strings for a while. So name equals Susan. If I want to tack something onto that, I can use concatenation. Name equals name plus a space, a quote, space, quote, plus, wait, let's do it like this. Name equals name plus quote, space, B, end quote, semicolon. Right. So it's going to, when we're done with that, it's going to say Susan space B. Let's just prove that to ourselves. Print, parentheses, name. That is concatenation. Concatenation is when you tack on one string to another. Appending it, gluing it, I think this textbook calls it, or at least another one does. I forget which one. All right, now let's tack on Anthony as the last part of this string. Now this is a long form, name equals name plus B. You can do the short form, name plus equals, quote. And if I just put Anthony here, then there's going to be no space between the B and the A, right? If I just put Anthony like that, and run, I won't like the results. Well, I don't like the results because I didn't print out the variable, right? How about I move that print name to underneath that business? Print parentheses name. All right, so Susan Banthony. Nah. So I'd either need to stick the space there, or I could stick it there. Either's fine. Well, I'm curious about what her first initial is. That implies that I'm going to try to figure out what her last initial is, but I'm going to just play with that idea. So I'm going to print parentheses name square brace 0 in square brace in parentheses. That's going to print out an S. Zero-based indexing means that that's position 0, that's position 1, and that's position 2, and so on. And half the time when I'm reading out what I'm typing, I'm going to use the term subscript rather than the square braces. And if you hear the word subscript, just think a number between squares. So print parentheses name subscript 1 is going to be the U, lowercase u, and so on. I'm not going to do the whole string, right, because it's, 15 characters long. I don't feel like printing out 15 characters. I could write a for loop that would print them all out. Let's just run this and make sure that it does what I'm expecting it to do, which is to print out the name followed by an S and a U. All right, S, U. Since we talked about for loops last time, let's use a for loop to print out every letter. We need to know how long this string is. Yeah, I showed you one way of doing a for loop, right? We could just do this for ch space in space name colon print parentheses ch in parentheses. That would print out SUSAN space B. But I really wanted to do it with indexing. Even if it doesn't stick in our brain right now, even if it doesn't make, more than 10% sense, I do want us to use the other kind of array, which is a range-based array, which counts with numbers. Yes, sir?
Is CH, is that a predefined variable, or is that?
Nope, I just made that up. This could have been called Johnny.
Right.
Yeah, the question was, is CH a predefined variable? No. I just tend to reuse them over and over, and you've probably seen me use CH.
I thought it meant character.
It does. That's what I'm using it as.
Okay.
That right. But this would work just as well. If I run it, it's going to print out the letters of the name all in a row like that. But variable names are just for our benefit. And so CH for character made sense to me.
Yes, sir. The reason why I asked is because sometimes I in the past, I think I've seen CHAR.
Right, CHAR is a keyword in some languages.
Okay.
Not in Python, but
Not
yes,
in Python.
in Java and C, C++,
Right,
it
okay.
absolutely is.
Got it. Thank you.
So I want a way of printing out all the letters using that index value. Well, let's just make it something that will print out the numbers. If this thing is 15 characters long, like I estimate it is, then I'm going to need the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to need all those numbers. Tell you what, that string's too long. Why don't we reassign name to something else? Name equals, Luke in parentheses. So I need something that's going to count from 0, 1, 2, 3. So I can use that 0 and that 1 and that 2 and that 3 as index values. How about a range-based for loop? My favorite variable names for range-based for loops are quite often I or X. For I in range, parentheses, and I need to know how long that name is. len, open parentheses, name, close parentheses, close parentheses. What this does is it checks that string, counts how many letters there are, and returns it. So since Luke is 4 long, the length of the name is 4. So it's going to start counting 0, 1, 2, and 3 and stop when it gets to 4. So in this particular case, this is going to count 0, 1, 2, and 3. And I think on Tuesday when I lectured, I used a first place here, like starting counting at 0 or starting counting at 1 or something like that. So I'm going to go ahead and put that there. But if you leave that out, it does start at 0 anyways. But this range statement means start at 0 and keep going up to but not including this second value. So it's going to start at 0 and it's going to count 0, 1, 2, and 3. Let's prove that just by printing out I. Print I. And we should see the numbers 0, 1, 2, and 3. There we go. Matter of fact, we did. But now we have I that we can use as an index into the name, just like I was doing here. Right? So I can print I, comma, name subscript I in parentheses. And so it's going to print out the letters of the name string and their positions. So 0 is going to be L, 1 is going to be U, 2 is going to be K, 3 is going to be E. There we go. Just a little bit more I want to do with indexing. Then we're going to hit the chapter again. What if you want more than just one part of the string? What if you don't just want one letter? What if you want the first 3 letters? What if our name was a little bit longer? Name equals, quote, Vader, end quote. And I just wanted to print out the A and the D. I use something called slicing, which looks a lot like indexing. It uses the squares, but inside the squares you don't just put one number, you put 2 numbers separated by a colon, like this. Print, parentheses, you don't have to add the space that I just did, name, subscript. Now this is position 1, right? So I'm going to start it at position 1, and then colon, and I want it to go up to but not include the E, because I only want A and D. So just like the range statement, I'm going to have to put one more where I really want to stop. That's 0, that's 1, that's 2. So I better put a 3 there, because that's 0, that's 1, that's 2, that's 3. And just like a range statement, it means start counting at 1 and go up to but not including 3. So that's position 1, that's position 2, up to but not including 3. So it's going to print AD. close our subscript, close our parentheses. And when we run it, it's going to print 80. As a matter of fact, I'm going to put a comment to that effect. This is known as slicing. I'll even add a comment to that effect. This syntax is indexing, or subscript. This syntax, x:y, is known as slicing. And it works with lists as well as strings. So if we had our good old list 8675309, we could get just the first 3 digits of it with a slice. Let's do that. We have a phone number, pnum equals, and I'm going to create a list using the angle braces. And again, it's totally fine if we're not getting this yet. If you haven't had fundamentals, then this is, and no other programming language, then it's going to look a little bit like Greek, but that's okay. You're just absorbing it, right? You got to watch some soccer games before you get out on the field. So here we go. Pnum is equal to 8, 6, 7, 5, 3, 0, 9. That's our phone number. But I just want to print out the last 4 digits. Well, somebody count it out, and using zero-based indexing, tell me what position the 5 is in.
3.
Yeah, it's in 3, right? 0, 1, 2, and 3. Okay, so why don't I do that? Print, parentheses, pnum, subscript. Now, I'm not going to do it perfectly. Right now, I'm just going to close the subscript right there. I'm not using slicing. So it's going to print out that 5. But really, I wanted to print out the last 4 digits. But let me make sure it prints out the 5 first. Yep. But I wanted to print out this position, and this position. Well, that's 4 characters. Now, rather than go, I'm going to count it out and up to but not including this position, I'm just going to take this length, 4, I'm going to add it to 3 and say, okay, I want you to start at 3 and go out to 7. Up to but not including 7. And if I count it out by hand, I'll find out that that's correct. That's position 0, 1, 2, 3, 4, 5, 6, right? So it would stop before 7, so it actually works. So what did I do? I found my starting position, and then for my second number, I just took my first position plus the length. If I wanted to go from 6 to 7, my starting position would be 1. The length of this is 2, so I would make my second digit 1 plus 2 is 3. And so this will print out 5, 3, 0, 9, but separated by commas because the list is separated by commas. Oops, I better put a comment there or else it's not going to compile. That's about what it's going to print. Maybe it's going to put square braces around it. Let's find out. Bless you. So there we go. It printed out the last 4. And it did put square braces around it. What did it do? It created a new list that was kind of a sub-list of this, starting at position 3, which is that, and going up to but not including position 7. So that's what slicing is, creating a new list. If you leave out the second digit, it assumes it's supposed to go to the end. So conceivably, I could have just left out that 7, and as long as I had that colon there, it would have worked just fine. It would have gone to the end anyways. But I'm going to put it back for now. All right. Anybody need eyeballs because you got syntax errors that you wish vanquished? Not yet? Dang, I needed my exercise. All right. Let me come back there. Alrighty, so debugging tips. If I had left off that, and then when I tried to run it, it would show that as a syntax error, and you could go nuts. I did not misspell the word print. It is not invalid syntax. You're right. If you're ever stuck and it's showing some line that looks perfect as being the cause of the problem, scroll your eyes up to the line immediately above it, and quite often you can figure it out. In that case, it's this. Here's another example. What if I'd left off this parentheses? Very plausible. Unexpected EOF while parsing. And yeah, it's showing some problem way down here, right? I've hit enter a million times apparently, and so it's even off the screen. But even if I got rid of that, and then I try to run it again, unexpected EOF while parsing. Now it kind of gave me a clue as to what line it's on, but it didn't have to. If I'd had a couple of blank, returns there, it would show the problems being there. All unexpected EOF while parsing means is that it hit the end of the file not knowing what to do. And why didn't it know what to do? Because we had an open parentheses without a closed parentheses. So if you get unexpected end of file while parsing, the problem is probably that there's a missing closed parentheses or a missing quote or a missing close brace, something like that. So we've talked about concatenation. Usually you do concatenation with the plus sign, but you can also use, in this language, it's the only one I've ever seen it, concatenation using the asterisk. So if we do this, print name times 2. It's silly to think about multiplying Vader by 2. What it's going to just do is concatenate Vader against itself and print out Vader, Vader. So if we change that to 10, we know what it's going to do. Vader, 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 Vader. Like that. Would you ever want to do that? Probably not, but there are 2 times when I find concatenation using multiplication, the asterisk, to be useful. One is just to draw like, a blank line or a series of dashes or something. Print, quote, hyphen, end quote, asterisk 80 in parentheses, and it's going to print 80 of these guys in a row. For whatever purposes. Right. Maybe I'll change that to 50. It went off the edge of my screen. The other is if I want to declare a list of values of a certain length. And I'm going to show you a syntax that I'm absolutely not expecting you to remember this time. But if I wanted to, I could do pnum equals, I'm going to erase this value and replace it, square 0 in square times 7. And what is that going to do? It's going to allocate room for 7 numbers. And so if we print it out, print parentheses pnum, instead of seeing 8675309 or just 5309, we're going to see 7 zeros in a row. The reason I'm showing this to you is you may have had another language where you had to allocate arrays. Or maybe you took my fundamentals class and I had already shown you how to do that. It just created a list of 7 values. I'm going to add a comment there. Create a list of 7 zeros. I really do not mind if you are not getting, right, with quotes, all this stuff about indexing. You do not have to type this comment, right, about indexing and slicing and lists, right? I like giving people sneak previews of what we're going to hit later so that, if we keep mentioning it, kind of like when you're trying to learn French, sometimes the instructor will speak only French in that class, nothing else, and so you're hearing all the words even before you understand them. And I'm glad I'm not in that class. So a variable is something that has a name and a value. It also has a type. There are rules for what you can call variables and what you cannot. I'm going to open up a multi-line quote so that I can talk about the rules for variables. And not just variables. This also works for function names and class names. The official name for a variable name is an identifier. But for now, variable name is such a good term, less computer science-y. Variable names, they can be letters, digits, underscores, but cannot start with a digit. That's the only rule. So, tax rate 2019 is totally valid. That's a good variable name. Tax underscore rate underscore 2019, that's valid. 2019 tax rate, that's invalid. Can't start with a digit. Cannot start with a digit. No spaces, right? Letters, digits, and underscores. So tax space rate is invalid. Some people like to use underscores. Some people like to use what's known as camel case. So you could also do tax rate 2019. That's fine. And then, by the way, it's also called camel case because it's got a hump in the middle. Did not make that up. I know y'all who've had prior programming languages have heard that term. That's known as camel case instead of uppercase and lowercase. In general, lowercase variables are preferred with camel case. If you define something as uppercase letters, it's implying that it's a so-called constant, which is a number that should not change in the program. Like if the maximum number of files that your program is able to open is 30, then you could do that. You could say max underscore files equals 30. The fact that it's in caps implies it's a constant, meaning that your code should not change it. So your code should not try to change it. Should not. Come on, hit enter. There. Not try to change it. And why do I use the word should? Because Python doesn't actually support constants. Java does. You use a certain keyword. Don't put this because I'm going to erase it immediately. You put the word final in front of it, and it means that's a constant. It cannot change. C, C++, C# use a different word. Don't put that either because it doesn't work in Python. It makes a variable called max files that cannot be changed. But here we're just putting it in uppercase to ask any other programmer who comes along to not try to reassign the value max files to something else. Just kind of a gentleman's agreement. We have this variable, it has a piece of data, please don't change it. It's important that it stays the same. Yeah, you can edit it and change it in the editor, but later on, don't reassign it to something else. Did I hear a question about to be asked about this? I thought I did. All right. So constants you could use like for, a file name that you were going to save your data to. Or, the maximum number of lines in the file that it's supposed to read, or the, some mathematical constant, the value of e or pi, or, that kind of thing. So invalid because it has a space, invalid because of the numbers. You can do goofy stuff like this. It's valid, but silly. We will probably get to a point where we will actually see some variable names that begin with an underscore. A variable name that begins with an underscore means something very, very specific, and I'm not even sure how to explain it. So just for now, don't create variable names that begin with an underscore. It looks silly. So those are the rules for variable names. Variable names should be meaningful. Meaning single letter variable name are for the birds, but I use them anyways because they're so easy to type. They should be words, not single letters, or combinations of words, right? Tax rate. But we use single letters in this class just to make things easy to type. Don't have to type that, that's just a comment for you. In your programming, I would rather you use, weight rather than W, and height, W than H. But I will understand it if you use H and W, but it's more professional to use longer variable names. So avoid single letter variable names except for counters. single letter variable names. So avoid single letter variable names except for counters. If you're going to make a for statement for I equals, for I in range 1 to 20, there's no reason to make that I letter a really long variable name. It's just, counter. They are case sensitive. Weight is different from weight, which would be different than weight, right? Tip, begin each word in the variable name with an uppercase letter. Very common way of doing it. If you were started programming in the 70s, you probably used underscores. After that, this became the most common way of doing it. The only reason I don't follow that in class is because I guarantee that if I use the word interest rate somewhere in my program and we wind up using a variable name more than once, then people are going to have problems compiling it because somewhere else they will have called it interest rate with a lowercase r, and then they probably later on had interest rate with an uppercase, whatever. So just to make things easier to type, I'm going to be using underscores. Just realize it makes you look old-fashioned and that this is the better way to do it. Better is not the right term. It's like wearing a top hat, right? So an assignment is when you give a variable, followed by the equal sign, followed by the value. The equal sign is called the assignment operator. Full name equals first name plus a blank plus the second name. And then if you printed out the full name, it would say Ken space Lambert. We put the word Ken, the string Ken, into that variable. We put the string Lambert into that variable. And we told it to take the first name, concatenate it to a space, concatenate it with the second name, and store the resultant full name, so when we printed out full name, it would print Ken space Lambert. You have to declare your variables before you use them. If I tried to print out full name before it had been created in this line, I would have gotten a syntax error. Now here's a very common mistake. Please don't type what I'm about to type because it's totally wrong. I am going to close my multi-line comment now so that the code would compile if I wanted it to. So I just tacked on the 3 quotes. Feel free to do that. But like if I give you a formula for calculating the radius, sometimes people will put that formula right at the very top. Right? So if I want to calculate the area of a circle, the area is equal to 2 times pi r squared. So, right. So pi times radius to the power of 2, right? And so they put that, don't put that. They put that at the top, and then later on in their code, they ask for the radius. Radius is equal to float, parentheses, input, parentheses, quote, what is the radius? Or they do it, in some longer format than that, which is fine. You can do that in 3 statements rather than 1. And then it crashes. It keeps crashing on that line. You don't define your formulas up at the top of the code. Instead, you put them where they need to be. You put them after the variables that they rely upon have been created. That variable is not created. And oh, by the way, that one hasn't either. But that variable certainly has not been created. It's not created until this point. So that line would always fail. It would never compile unless we moved it there. Yes, sir?
Instead of setting that pi as a variable, couldn't you like import math?
Right. The right way to do that would be to import math.
Okay.
So if I wanted that line to work, I could import math, or I could import pi from math, something like that. I believe that would work. Then I would not have to define the value of pi. Very, very good point. Okay, and I just deleted all that, so I really hope you didn't type it. So variables serve 2 purposes. They help the programmer keep track of data that changes. They allow the programmer to refer to a complex piece of information with a simple name. Program comments. We know what a program comment is. It's something that begins with a hash, with a pound sign. However, there are longer forms of comments known as doc strings. And your doc string up at the top of the code could contain the name of the file, the author of the file, the date that it was modified, and a written explanation for it. If I was cool and awesome, I would make, and you're going to go, no, I hope you don't do that. I would require you to put this up at the top of your code for every program you write. I'll contemplate it. End of line comments is when you use the pound sign. Rate is equal to 0.85. What does that mean? That's the conversion rate for Canadian to US dollars. Apparently this is going to be a constant, so they made it uppercase letters. What do you use single line comments for? Well, we've seen several already. It just describes something about the line, right? I ought to give a better comment than just putting 0, 1, 2, 3. I ought to say creates a loop that will increment I from 0 to 3, right? But anyways, or you can put them on their own line to explain parts of the code. You know, pound sign, get the height and width from the file. And then later on, pound sign, calculate the area and the perimeter. And then later on, before the final output, pound sign, output the results. Right? So you can describe sections of code. There's just like, you know, titles, paragraph titles or whatever with comments. Or you can put them at the end of a line to describe exactly what that specific line is doing. You don't have to go nuts and put a comment on every single line. If you did that, it would make the code actually harder to read. On the other hand, no comments at all is also a problem. You ought to put just enough comments in to explain what your code is doing. Now, our programs are simple enough that it's probably pretty easy to tell what our programs are doing at this point. But we're still going to be putting comments in them. I still want you to put comments in them, explaining what the code's doing. And I'll try to be good about telling you when I'm adding comments for that purpose. Just making sure it's counting. Yep, okay. So tips related. Begin your program with a statement of purpose. The purpose of my program is to get a good grade. Yeah, maybe it's supposed to be a different statement of purpose. More like this. The purpose of the program is to compute the area of a circle. And other information helpful to programmers. This program uses the turtle library to draw a flower. Right? Something like that. Accompany every variable definition with a comment that explains the variable's purpose. So like if I have weight equals, input, I might put a comment in there explaining that I mean the patient weight as measured in kilograms or something like that. Precede major segments of code with brief comments that explain their purpose. Just like I said, you might have a comment that says, gather the height and width of the rectangle from the file. So you can put that as a comment, and then you have 5 or 6 lines of code underneath it that actually perform that. And include comments to explain the workings or complex or tricky sections of the code. If something looks weird to you, it's certainly going to look weird to the next person who looks at the code. Or when you come back and look at it 2 years later. I've looked at code that I wrote 10 years ago, and I can't figure out what I'm doing because I didn't put the comments there that explain it. So the first application of computers was to crunch numbers. Numbers are still very important. What do they mean by that? Well, computers were used, like I have said this before, by the Americans to build artillery tables and calculate, things for, atomic bombs and stuff like that during World War II. That's the primary motivation for making computers. It was to assist the war effort to build, better weapons. And in England, it was to crack codes, to crack the Enigma code that the Nazis were using. So in real life, the range of integers is infinite. However, computers' memory does place a limit on the magnitude of the largest positive and negative integer. Python's typical int range goes from 2 to the power of 31. In other words, 2 times itself 31 times. Yeah, that'd be a pretty big number. Real numbers have infinite precision. Like 1 over 3 is 0.333 carried out to infinity, right? Pi has an infinite number of digits. However, computer languages have limited amount of memory, right? You don't have a computer with an infinite amount of RAM. And even if you did, then it wouldn't be able to represent it in its chip in that fashion. So Python uses floating point numbers to represent real numbers, and they can be a number with about up to 308 zeros after them, or with preceded, decimal point followed by about 307 zeros followed by a number, with a precision of 16 digits. What does precision mean? Well, if you've taken a chemistry or physics class, you know what precision means. If I do this, that thing's got 4 digits of precision. If I do this, it's got more digits of precision. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's about as precise as it would allow. If I start attacking on extra numbers, like if I said x is equal to, and then, like that would not work. It would round it off to what, 15 or 16 digits. Now, that doesn't mean 15 or 16 places after the decimal point. It means digits total. This would work just as well. Still 16 digits of precision. Maybe 15 if I accidentally deleted too many, but you get the idea. Or whatever. What if you needed to store this number? Right? A period followed by all those zeros, followed by, these are the digits of precision, starting from there to there. Preceding zeros don't count as far as precision is concerned. Don't worry, you're not going to really have to know this stuff in the future, but I'm trying to explain what precision is so that you can think a little bit more like how the computer is going to handle the data. So what is it going to do? It would store this number as 1.123001234 times 10 to the power of, some negative number. It used scientific notation inside itself to contain that value. It could have up to 308 digits before it. 308 zeros before it, or at least 300 zeros before it would work. It would use scientific notation in order to convert something like that into something that's actually storable in the computer's memory. So floating point numbers, you can use scientific notation inside your code, or exponential notation, I should say. Maybe it's called scientific. I guess that's what they call it, so I could call it that too. Decimal or scientific. So if we have this, x equals 340, that's the same thing as x equals 3.4 exponent 2. I don't care if you know that. I don't care if you know what that means. But what does it mean? It means 3.4 times 100, which is 340. It means move the decimal place over 2 times. If you need to represent numbers with scientific notation, you have the ability to do that. This means 3.4 times 10 to the power of 2. That's what that means. And if I do this, x is equal to 3.4 exponent negative 5. What does that really equal? It equals 0.123434, like that, because it equals 3.4 times 10 to the power of negative 5. That's just scientific notation. Like I said, you're not going to be given a pop quiz on how to do scientific notation. But I'm sure that you've used calculators before in other classes, and if the number gets too large, it switches over to displaying with an E, right? Which is the number of zeros, that, the place value of it. Same here. If our values get too large, then Python's probably going to switch over after a certain point to printing them in scientific notation. And you can probably control that through some formatting specifications. Say, I want you to always print this just as a series of numbers without an exponent. But it will. So if the values get large enough or small enough, you may see it switch over to scientific notation. calculate the number of atoms, on the planet, that's going to be a pretty huge number. It would probably display it in scientific notation. So Python uses something known as Unicode or ASCII. I'll probably be talking more about ASCII later. I may have already mentioned it. It's just a system for storing text in your computer. Because if you type ABC, your computer doesn't know what an A is. It doesn't have a place in RAM for holding letters. Computer memory can only hold numbers and only numbers, zeros and ones. And so there has to be some system that says, oh, by the way, if you have this number, I'm going to pretend it's an A. And if you have this number, I'm going to pretend it's a B. And if you have this number, I'm going to pretend it's a C. And what do I mean by pretend? It's for human purposes, so that I can type in ABC and have it recorded to disk or memory, and then later on pulled back out of memory or disk for display on a screen, and I'll see the letters ABC. Or if you're transferring data over the internet, right? Over the cell phone wire, radio waves, or over a modem, who uses modem anymore? Or, your Ethernet cable, things come in as zeros and ones, they come in as numbers, and so the letters ABC to be displayed on your screen are actually going to be encoded as a very specific series of bits. And we can find out those values by going to a thing called ASCIItable.com. If we go to ASCIItable.com, I will see that an A, I just happen to know this, is a 65. And a B is a 66, and a C is a 67. So if I type in ABC in my computer and then I save the file to disk, then somewhere out on my disk are going to be three numbers in a row, 65, 66, and 67. Well, that's the way that the data is stored internally. So if I do name equals Fred, then the Fred is actually the numbers F-R-E-D that I could look up in that table. Now this is showing that every letter has a value. Let's play with this a little bit. I think by the time it goes on a little bit further, they show some code for creating what's known as Caesar Cipher. It may be in this chapter. If we go here and we do print parentheses, ORD parentheses, quote A, end quote, in parentheses, it's going to print 65, just like I said on that table. And if I do a B, that's going to be a 66. If I do a C, that's going to be a 67. Now why don't we print out some other things? So I'm just going to copy and paste that and just put in whatever you want, whatever single character in here. How about a space? Or how about a question mark? Or a lowercase a? You don't have to pick the same characters. You can put the letters of your name there, right? Fred, F-R-E-D, whatever. And there we go. 65, 66, 67 as promised. A space happens to equal a 32. I guess a question mark is a 63. And a lowercase a is a 97. I could go to ASCIItable.com and find out that whether a space really was encoded as a 32 or not. If I look it up, yep, a 32 is supposed to be a space. A lowercase a is in fact written in computer memory as a 97. And a question mark is whatever it was. So that's the ordinal value of the character. ORD returns the so-called ordinal value, which is just a numeric value, which is just the ASCII or Unicode numeric value. What does Unicode mean? Well, ASCII is not large enough to hold every letter on the planet, right? There's Korean and, there's, Arabic and Iranian and, Farsi. There's no Iranian character set, but there's a Farsi character set. And, German languages with their diacriticals and umlauts or whatever, far more than 127 characters or 255 characters. So there's a character set which encompasses ASCII. It starts with ASCII, but it goes on and on and on, so that you can also encode the French characters and the you know, in German and Chinese and the emoticons so that you can have happy faces and sad faces and, you know, and water droplets or whatever you needed to send over your cell phone. You can convert a number back to a character. We keep saying that 65 is an A. Well, yeah, let's find out. Print, parentheses, CHR, parentheses, 65. In parentheses. That's going to print out an A. Print, parentheses, CHR, parentheses, 37. I made that number totally up off the top. I mean, I don't know in advance what it's going to print, although I have a hunch it may be a 30, it may be a 6. Let's find out. And I just add the extra spaces to make it easy to read. You do not have to put them. Oh, it was a percent. So 37 is a percent. If I went to ASCII-table.com, I would in fact find out that a 37 is a percent. So there's something called Caesar's Cipher, which is what would happen if you took all the A's and you wrote them down as B's in your document, and all the B's and you wrote them down as C's, and all the C's and you wrote them down as D's or whatever. Then when somebody else got that document, they'd have to do the reverse. Everywhere that they saw a B, they'd have to replace it with an A, and everywhere they saw a C, they'd have to replace it with a B, and so on. So you'd just be shifting it. So A, B, C shifted becomes B, C, D. But you could also shift by 2 characters rather than 1, or by 10 characters, something like that. I'm expecting to see some code for that pop up, but I'm not quite sure it's in this chapter. It would seem to me a little bit premature to do that. But I know that people have already sent me questions over Caesar's Cipher. Let's see. So expression. An expression is, well, that's an expression, but you don't normally think of it as an expression. It looks like a value, right? That's an expression. This is an expression. It's a series of values and symbols, right? It can just be one value, like a 3, or it could be one variable, or it could be 2 variables, or 20 variables, you know, if you're multiplying A times B plus C times D divided by, you know, H, whatever, that's an expression. So, a literal evaluates to itself. That's a pretty cryptic statement, but if you have the number 4 in your code, it means a 4. A variable evaluates to the current value. So if you have x set to 10, then whenever it evaluated, like if it printed it out, if you had set x to 10, it would print out a 10. An expression allows you to hook up the data values together to produce other data values. So like 4 plus x, well, if x was, what did I say, 6 or 10? If x was equal to 10 and then we added 4 to it, then it would print out 14. So if you enter at a Python shell prompt, it goes ahead and displays the result of the expression. So if I go into idle, find my shell, I'm going to start a brand new shell so that it's not tucked away at the bottom. So I'm going to do run Python shell. I can do this, A equals 3, and then if I just type in A, since I'm in the shell, it displays a 3 without even putting the print keyword, print function. A times 2 is a 6. That's an expression. A plus 3 to the power of 2 times A minus A divided by 2. Whatever, right? That's an expression. It's just a series of values, which can be either literals or variables, separated by the operators, the math symbols. That's an expression. And then the computer evaluates them when that line of code is executed in order to do something with it. You can calculate radius, right, or convert from one temperature to another, or convert the amount of energy contained in this object moving at this rate, or whatever problem you're trying to solve. How are we doing on the syntax errors, gang? Please interrupt me before I go too long, and I have gone too long. So arithmetic. Yeah, maybe we'll do a math program. Have we already done one? Minus just means negation. But you don't use minus a to mean negative a. But we do that with digits, right? This is called a unary operator. Unary meaning one operand. Okay, that's getting way off the bat. Let's just look at the symbols first. For getting this line, we know that we have addition, we have subtraction, we have division, and they're calling this quotient. Other textbooks call it floor division. Why don't we mess with these ideas? Go ahead and get a shell going. Launch idle, click run, Python shell, and let's just play with these ideas. 5 plus 2. Surprise, it's equal to 7. 5 times 2 is 10. 5 star star 2 is 25. 5 divided by 2 is 2.5. 5, it's calling it quotient. 5 floor division 2. Floor division means round it down after getting the result. So that's 2. 2.5. It dropped the 0.5. Now 4 divided by 2 is 2.0. 4 / which is floor division, equals 2 as well, right? There was nothing to drop. So this symbol is called the operator. That's an operator. That's an operator. That's an operator. That's an operator. That is, and so is that. Operands are the pieces of data that the operator works on. The operator is a plus sign. The operands are 5 and 2. The operator is normal division, and the operands are 4 and 2. This textbook mentions that integer division rounds down, which is absolutely not true for Python. So if I find that slide, I need to delete it and re-upload it. In some languages, if you do 5 divided by 2, it's just equal to 2. It rounds it down, which is really irritating. Not in Python. In Python, 5 divided by 2 is equal to what you expect, 2.5. So we're going to have a homework assignment based on the idea of doing these operators. Here's what the homework assignment is going to be. Write a program that asks for the user's first name and then the user's last name, then prints out hello followed by their first and last name. That was pretty easy. Then let me make sure that I'm not making an exact duplicate of a homework assignment that we've already got. Excuse me for zipping over here for a moment. Simple conversions. Compound interest calculator. Maybe we'll do that one. Maybe I'll just delete what I told you and then assign this one instead. So, I'm sure you know the idea of interest. Not that bank accounts give interest anymore, right? You used to be able to get a checking account that had a 1% interest or whatever, but you can still get certain kinds of accounts, IRAs or something that will allow you to get a certain amount of interest. You certainly get charged interest for credit cards, right? You get a 22% interest, on your money, which means that, if you put $100 on your credit card, by the end of the year, if you haven't paid anything off, you're going to owe at least $122 back, probably more because of late fees and stuff like that. Anyways, this is the formula for calculating compound interest. And it's written all with single letter variables, which I told you to ignore, but not to do, but your program may as well use single letter variable names because this formula shows it. So what is P? P stands for principal, the starting amount. You owe $100 or you put $100 in the bank, something like that. And then there's a formula for calculating the amount, the ending amount, based on the starting amount, the interest rate, like 0.10 for 10% or 0.5 for 50%, followed by N, the number of times per year, which is just usually monthly, right? So that's usually going to be a 12, to the power of N times T. So how would I express that in computer ease? It would look something like this. I'm just going to delete that part. We don't care about asking the user for their first and last name. We're doing the interest problem. Okay, so if I have already asked the user for P, for R, and then N, and then T, I could calculate the interest like this. A, which is the final amount, is equal to P. Now I can't just do this. I can't just put a parentheses there. In programming, you're not allowed to assume that because two things are side by side, they're getting multiplied by each other. So P asterisk, to do the multiplication, parentheses, 1 plus, whoopsie, 1 plus R over N. Okay, cool. R over N, but we're gonna, why don't we just assume that N is equal to 12, but I guess we shouldn't. Let's follow the equation exactly. And then close our parentheses. We see a parentheses closing there. And if I did this, that means to the power of. And then if I did N times T there, can somebody tell me what's wrong with that? Because you've had another programming class in the past or something.
It's going to do the power to the power of N.
Exactly. It's going to do this first, and then it's going to multiply the result by T. Whereas what we want it to do is to do this part first, and then take it to that power. So this part needs to be inside parentheses. So your program will ask the user for P, the starting value, the principal, R, which is, I'll tell you what, the interest rate expressed, in decimal form, like 0.10 is 10%. Just so that when you're testing it, if you type in 10, be warned that your answer is going to be like in the millions of dollars or whatever, which would be great, but because it means 1,000% interest. Then we're going to need to ask for N, or we could just assume N is equal to 12, but let's ask for T. T, the number of years. Assume N is 12. So just put N equals 12 above the formula. Then calculate the accumulated total using the interest formula, compound interest formula. A is the total. Print out the total.
When you say T equals the number of years, you mean number of months, or is it?
It's actually years. I just double checked it.
So that's years?
Yep.
So we're doing this over a 12-year period?
I didn't say anything about setting t to 12. I said set n to 12 because n is the number of times per year, so it's the number of months.
Oh, okay, got it.
Right, right,
Okay.
right, right,
I
right,
was looking
yeah.
at T when I was thinking it. All
Right, okay, so the program ought to look something like this. What is the principal? Where is it at? I don't remember. You type in $1,000. What is the interest rate? You type in 0.10. How many years will we calculate? 10. The final amount or total amount, including interest, is 1,137 or something like that. That's not the actual value. We could figure it out. We could just enter this into the shell with those values, and we actually get the final value just so that my instructions show it right when you test it. Okay, so our starting amount is going to be P. P equals 1,000. Our interest rate is 10%, so 0.1. N, number of times a year, is 12. And then T is, I said 10 years. And then so our formula was A, and you're going to put this all in the program, not in the shell. A is equal to P times parentheses 1 plus R over N in parentheses star star N times T in parentheses, and then print out A. Okay, that's the final result. And let's make a Dropbox so that people can leave. Then I'll bring that back up, and of course I'll post the instructions as well.